The first step of computerizing our paper recording system is to identify the data we have and then decide what the type of that data is. And what do I mean by the type of data? If I said to you, add together the numbers 3 and 27, you could do it easily. But for a computer to add two numbers together, we have to tell it what type those numbers are. For example, whole numbers for 3 and 27, or real numbers for 3.0 and 27.0. We do this in a programming language. In some languages, such as Python, it can infer the type of data, whereas in others like C++, we have to be more specific. Of course, inside a computer, everything is stored and used in binary, but a programming language allows us to use something which is closer to our natural language. As I mentioned before, computers need to be programmed by us, and we do this by providing them with data and a set of instructions that tells them how to process that data. Usually computer languages have two different sorts of data types. Primitive types such as integer, real, boolean and char, and more structured data types such as strings and dates, as well as user-defined types called records, and collections which hold sets of other types like a list of integers or a list of dates. But more on these later. Some of these types are built into the language, but not all languages support the same built-in types. For instance, Python doesn't have a char data type, whereas C++ does. Anyway, the key thing to remember is that the type of the data defines what you can do with it. For instance, when I use the plus sign to add the two integers 1 and 3 together, you get 4. But using plus when they are strings gives you 1, 3, as the strings are stuck together as characters. Let's go through our paper system and decide the types of data we need. We'll keep things simple to start. The data types we're interested in are the filled-in values of our paper system. Looking at the table, the first thing is the date we counted the ducks, like September the 1st, 2022. Even though it's a date in real life, we don't need to computerize it as a date type, as we've no need for it behaving like a date. It's just something we want to record. We might decide otherwise later though, so for the moment we'll just make this a string type, which is just a bunch of characters. Next we have the actual count of ducks, one for each breed. These are numbers of course, and are positive integer data types. They are whole numbers rather than fractional numbers. They're also positive as we can't have less than 0 ducks, and whole because we can't have half a duck. Now could we make them strings? Not really, as we want to use them in calculations, which is of course numbers. We also have to associate each of the counts with the breed of duck. The breeds are of course strings, and we have a list of them across the top. In programming there's a concept of a list, so we'll use that both for the list of breeds and the corresponding list of counts. There's also lots of count lists, in fact there's one per day. I'm going to use the list of breeds as a way of finding the corresponding count. If I number or index the breed so that Ida is the first item in the list, Cadwal is the second, up to Widgeon being the 10th, then I can use its position in the breed list to get the value of its count from the count list. So for instance, Gadwal is the second item, so using the count list from 5th September, I count 2 in to get the value of 20. Of course, for us humans it's easy, we just use the row and column from the sheet and look it up, but computers don't work in that way, so we have to organise our data and tell it how to find something in that data. Next there's the total and average values. The totals are calculated by adding up the individual duck counts for a day. So for instance, the total for the 1st of September is 100. The total is therefore a positive integer. The average is the total number of ducks for a particular month divided by the number of days a count was taken in that month. So for example, if we saw 1,575 ducks in September, then the average would be 52.5 ducks per day. Of course, by average we're referring to the mean. The average is a positive real number. It's a real number because real numbers have a fractional part. Well, that's data type sorted for now, although we'll probably change a few things as we go. One thing to note is that when you become more experienced, you'll do this identification and typing of data in your head as you develop your program. Anyway, the next video looks at the steps we need to go through manually to record and calculate with our duck counting system. These steps are known as the functionality of the system, and after that we get ready to start coding.